Thanks for attending this afternoon. We'll be starting up in just a couple of minutes. Thanks. Everybody, this is Eric Pearson from Exida. We'll be starting up in just a minute or so. Give a minute or so for some more people to sign on. Good afternoon, everybody. This is Eric Pearson from Exida. Looks like the numbers are pretty well stabilized, so I guess we'll start this show. Thanks. All right. As I said, this is Eric Pearson. We're going to give a short presentation on the benefits and why and when to do a control system cybersecurity vulnerability assessment. So my name is Eric Pearson. I'm the Senior Cybersecurity Engineer with Exida. I've been with Exida about 4 years now and have experience both in the IT realm and in the industrial control system realm. And I perform the trainings, I've developed the training and perform the risk and vulnerability assessments for Exida. If you have anybody has any questions, they'll be addressed at the end of the presentation. If you type them into the text box, the questions box, I'll get them at the end and I'll address them then. Everybody on the remote side has been muted. There we go. So a short introduction, many of you have seen some of these before, but a short introduction to industrial control system security. And what is industrial control system security? It's basically what it sounds like. In very simple terms, it's keeping the bad guys out and the good guys in. The bad information out or the viruses out and the good data and good information in on the network where it belongs. It has a lot of different names depending on the industry and the people you're working with. It could be SCADA, PCN security, or industrial control system security, but it always means the same thing. Keep the bad guys out and the good guys in. So what has made industrial control system security so prevalent or so popular now? I wish it were more popular, but it's the vulnerabilities that have been developed over time or exposed over time. Among them is the fact that it used to be that industrial control systems were developed on proprietary networks and proprietary technology. And in about 25 years ago, give or take, it became apparent that Ethernet technology was going to be used to control a process control system. And so as the industrial control systems migrated over to standardized, commoditized technology, the integration of Windows versus either a proprietary operating system or a Linux or Unix-based operating system, and all of the vulnerabilities that come with a Windows operating system, the databases, the protocols used over an industrial control system network are the exact same protocols which are used on a business or a enterprise level LAN. So all the TCP/IP protocols that can eat up bandwidth and can be used to propagate viruses. And these same systems, the Windows-based systems, which are susceptible to viruses and worms and such, are now just as susceptible, if not more so, on an industrial control system network. Those viruses can propagate across the industrial control system and affect the process control equipment itself, such as the PLCs and the logic solvers. The fact, like I mentioned, that it used to be that a PCN or a process control system was a proprietary network, and if you wanted information off of it, you asked. However, today's environment, you usually have a centralized control room or a executive monitoring facilities where they can see what's going on the process control system. And all of that information which is being pulled off requires a connection somewhere down into the control system. Remote access used to be the realm of the elite. Now it's used by pretty much everybody to perform maintenance, to perform monitoring, to change settings, to check on things. It can be used 7/24 to gain access to the system, potentially the process control system. And public information. Manuals and information on how to run and, unfortunately, how to break a process control system is readily available on the internet. Also, the search engine called Shodan, which is essentially a search engine which has cataloged what they say now is 500 million devices, which are process control devices, which are open on the internet, accessible from the internet. And Shodan says they update 500 million devices every month. So all of these devices are sitting on the open internet to be potentially exploited in some way. So how can we get into the control network? There's a myriad of ways, and this does not even begin to cover them. But some ways, most commonly, infected remote support computers. A vendor needs to connect to your network, and so he makes a connection using a VPN, and that VPN allows traffic to flow, and he's got an infected system and potentially can put something onto your network. Firewalls that have been misconfigured to allow too much traffic to flow through. A vendor physically comes in and plugs his laptop into your network and exposes your systems to a virus, or simply a misconfiguration which can cause problems on your network. External PLC networks, where a centralized entity needs to connect to, let's say, a remote PLC. So in this case, true case, they decided to use a cable or a DSL link to connect the centralized system to the remote device. But they didn't firewall both either end of the connections. They basically were on an open connection that everybody who was also on that DSL or cable system could see those two connections. So they simply exposed themselves to unauthorized use, unauthorized connections. There's no telling what could happen. So why is SCADA or ICS security important? The easy answer is because when an enterprise network or business network is violated, you potentially could lose your email or your internet connectivity. When a process control system network is violated, it can go boom. You can have some real-world events happen, some catastrophic events happen on that network. Because process control networks monitor real-world inputs and outputs and control real-world devices, to keep control of that network is paramount. It's also been proven that industrial control equipment like PLCs, logic solvers, some scales, I don't have any particular names, but there's a number of them out there, are sensitive or susceptible to excessive network traffic, be it an unintentional broadcast storm or some operating systems essentially expose this equipment to a continuous state of a broadcast storm. For full disclaimer, the picture on the right is actually a picture that I took last week flying over Alabama. While this wasn't a cybersecurity event, it potentially could have been a physical access issue. This is the gasoline pipeline that exploded in Alabama last week. I flew over it about 15 minutes after it blew up. So IT versus ICS security. It's very common that the IT group either is involved or has complete authority over the industrial control system security. And while in some instances this may not be an issue, there has got to be education and a mindset which differentiates the IT security versus the industrial control system security. In the IT world, the most important thing are the data servers, the information that's stored in the central servers. If an end device is compromised or an end device is damaged or fails, like a laptop, it's usually not that big of a deal. We'll get you a new laptop at some point in time, but we need to protect the data that's in our centralized servers. In the ICS world, it's the end devices which are most important. It's the logic solvers or the PLCs that are sitting at the end of the wire that are actually controlling the process that you want to protect. If a server goes down, it's not a good thing, but it usually means a loss of maybe trending information or historical information, something like that, where generally the end devices will run autonomously long enough to allow you to effect a safe shutdown. So in the IT world, general consensus is the confidentiality of the information stored in the infrastructure on the network and in the servers is paramount. The payroll information, the corporate information, the recipe for Classic Coke or KFC, that's the important thing that they're trying to protect. The integrity of the network is equally important. What I think I've stored is what's stored. What I think I'm reading is what I should be reading. And the availability. The availability of a business network, if it goes down, it's not good, but it's usually not the end of the world. You can usually get away with not having your internet or not having your email for a little while the network is brought back up and running. In the industrial control system world, we can't accept that the fact that the network goes down. So the availability of the network is paramount. We need to keep control of our process, and the network is what allows us to do that. The integrity of the network is important. What I think is happening to my devices, what I'm reading from my devices, is actually what should be happening and is what I should be reading. And the confidentiality is important, but less so on a process control network. Because if you think about the information being passed over the network, for example, you sniff the network and you get the number 43. Well, taken out of context, what exactly does that mean? Is that a pressure? Is that a flow? Is that a valve setting? It's not as important that the information is confidential. You certainly don't want people reading and sniffing your information, but the actual data flowing over the network is needs to be less secure. Also, in the industrial control system world, IT has never had to deal with process safety. This is new to them. They had never had to deal with it before, but if they are going to be involved, and it's a good idea to have them involved, because security in the IT world is a long-standing curriculum. It's been happening for a long time. They know how to do it right. It's just the mindset that needs to change, bringing security, IT security, into a process control environment. So where does the requirement or the requirement for process safety start? Does it start with the automation suppliers who have to build better products, or the product developers, or the automation suppliers and the integrators who are putting these products together to create a system, or the end user that's putting the system in place and running it? And the obvious answer is it's everybody. It's the end user's final responsibility to make sure that they've received a system which is secure, but it's the automation supplier's responsibility to strive towards creating and building a more secure product. And it's everybody's responsibility to make sure that the security requirements are pushed in both directions. So recent standards have been released. IEC 61508 is being rewritten. IEC 61511 has been released in a new form. These are now calling out cybersecurity requirements where this was never done before, because it's becoming realized that in order to truly have a safe and reliable system, you need to account for the cybersecurity aspects of it. So following best practice, CFR 1910 requires operators of processes to follow best practice, and it's been recognized that 61511 is recognized as a generally accepted good engineering practice document. It's built around the safety life cycle, and as that it requires that risks be identified and mitigated. Some of the changes which have taken place in 61511 have specified that a risk assessment will be performed to identify the vulnerabilities of the safety instrumented system. This is strictly applicable to a SIS, and we're going to talk in a second how this needs to be expanded, how this view needs to be expanded. So in this case, 61511 specifies that a risk assessment and vulnerabilities need to be identified and mitigated when dealing with a safety instrumented system. It also says, note 2, that the risk assessment and the need for security will not fall with the supplier. In fact, it will fall with the end user. So the end user is responsible for assuring that the system they are running is safe and reliable. And this involves the cybersecurity aspect of it as well. So the functional safety in cybersecurity begins at the engineering feed, when the system is first being conceived and developed, is when cybersecurity needs to be accounted for. It needs to be looked at. It needs to be reviewed all the way through the life cycle of the process, the development of the system, the implementation and testing of the system, and the decommissioning of the system. Cybersecurity needs to be accounted for throughout the process. Now, we mentioned earlier 61511 was dealing with cybersecurity of the safety instrumented system, the SIS, the safety system. However, modern safety systems in many, many cases are physically connected to the same process control network that the general process is connected to. Many times, one of the computers on the network is the one that will control, modify, and program the safety system. So if an event on the PCN network causes a demand of the safety system because it's causing your process to begin going out of control, is there a chance that this same demand or same event that's putting a demand on the safety system also has the capability of keeping the safety system from responding? That's what needs to be accounted for. Do we need to segregate it better? Do we need to isolate it better? Do we need to look at it and make sure that any vulnerabilities in the safety system and in the generic PCN, so to speak, are looked at, accounted for, and mitigated? So this is where you start off with looking, like in 61511, a safety system, but you have to expand your horizons to begin looking at the entire PCN as well. So going back to the cybersecurity vulnerability assessment, when should you actually perform it? Well, it depends on the current situation that you're in, where you are sitting in your life cycle. It also depends on what you've done. And there's always the question, do I really need to do it? I've done some, I may not have done some, but I don't even know where I am right now. So one of the ways to determine what you need to do is using the NIST Cybersecurity Framework. The National Institute of Standards and Technology has developed a cybersecurity framework. The framework defines the terms functions, categories, subcategories, and introduces a tier and profile concept. And what you do is it goes through a number of what they call functions, and it identifies where you are and where you want to be. And it creates a gap, or it identifies a gap. So the functions which have been identified within the cybersecurity framework, and these are very similar to most other standards and regulatory documents that have been created. The 5 functions are identify, protect, detect, respond, and recover. Once you look at that, once you identify these, there are things called categories within the functions. So if we take the identify function, the categories under that function are asset management, business environment, governance, risk assessment, and risk management strategy. The subcategories under that is where you begin to get the detail. What the cybersecurity framework has done is created subcategories which are essentially questions, and how you answer those questions creates the potential gap. So in this case, physical devices and systems within the organization are inventoried. The tiers run from 0, I really don't even know what you're talking about. 1 is usually the lowest, saying, we know what it is, we're trying to do it, we really aren't that good yet, but we're trying. Up through 4, which is, we know what we're doing it well, we share our information with others, we receive information from others, and we make our process better by doing that. So in this case, we look at the first one and we simply ask the question of the end user, of the group that we're talking to the end user, how well have you physically inventoried your devices that are on your process control network? And in this example, we got back saying, we really don't know what's connected to our network because it's basically expanded over time. Okay, where do you want to be? We really need to know what's on our network. So the current tier is a 1 and the target tier is a 4. So going down to AM4, external information systems are cataloged, basically saying that we know What external systems are connecting to our PCN and are reading or writing information? In this case, we know what's happening, we know what it's doing, we have good control over it, and we've done as much as we care to do. So by going through all these questions, a very simple example here, you know right away that you can go back to management and you can say, we need to devote our resources and our efforts inventorying our devices which sit on our process control system. We are good enough for the time being in some of the other areas, but we need to start there and then work from the reds to the oranges to the yellows to the greens. So this gives the gap, and this gives you a direction which you can take to, again, apply your resources to where they are needed most. Most of the assessments that we are doing follow the ISA/IEC 62443 structure. There are very few industries which are truly regulated through a regulation standard, that being the power industry through NERC-CIP, the nuclear power industry, and the chemical industry through CFAT. Most other industries fall under a standard. You should do things this way, but there's no regulation to force you. Most of the assessments, in this case the vulnerability assessment, fall under the 2.1 category. The slides that are going to follow, I'm pulling out of the older ISA 99 versus the newer 62443, only because they're easier to see. But I'm going to show where they both have very similar, the same information. So pulled out of ISA 99 2.1, 4.233 as part of the requirement says to conduct a high-level risk assessment. Further on down, develop network diagrams, prioritize what you're going to work on, and then perform a detailed vulnerability assessment. This is where this webinar is discussing the detailed vulnerability assessment. Other webinars have discussed the risk assessment. In the new 62443 standard, there are similar requirements. They're called out a little bit differently. So in this case, C3.3.3.3, other words inside, but a detailed risk assessment as defined in this standard is supported by a detailed vulnerability assessment. And 33381, a detailed risk assessment and takes into account a detailed technical vulnerability assessment. So both documents still call out the fact that it's required to do some sort of a vulnerability assessment to pull that information into your entire process and use it during your detailed risk assessment. The working group TR84, which is chaired by one of the gentlemen who works at Exida, was originally chartered to develop the cybersecurity process safety lifecycle for safety systems only. Once they got involved in examining how safety systems are constructed and connected and what needs to be done, it was clearly apparent that the scope of the working group had to expand to include a lot of the basic PCN because of the way that safety systems are interconnected into the PCN itself. You can't just simply, the way it's done, you can't just simply cut them off. You need to look at everything, again, because that demand could be created by an event on the PCN which the safety system is connected to. So the new PSM cybersecurity lifecycle calls out the fact that you look at your updated design accounting for assessed vulnerabilities, and the pink box to the left says process hazard analysis with corporate risk criteria, vulnerability assessment, and audits. It implies that a vulnerability assessment should be performed, which then leads into the detailed risk assessment. The cybersecurity lifecycle developed by Exida, I made it a little more apparent. I made it a little more blatant, where it's pretty much the same steps. You do high-level risk assessment, and then if there's a current or relevant documented results are not available, or a vulnerability assessment has not been performed, then this step requires that you then perform a cybersecurity vulnerability assessment, which then leads into your detailed risk assessment. In my mind, it makes it a little bit clearer as to the steps which need to occur. When you're in a brownfield environment, it's less likely that you are going to perform the risk assessment steps first. And generally what's been accepted is you perform the vulnerability assessment, and that gives you immediately actionable items which you can do to harden your system or to control it or to lock down your system, including hardening system components like your Windows-based computers, control access to the system, be it physical or be it virtual access like user rights, segment the network to stop unwanted traffic from flowing across where you don't want it, etc. The vulnerability assessment, like I said, gives you instantly actionable items which can be used to harden your system or to lock down your system. So what's involved in a vulnerability assessment? Basically, it's looking at the system as a whole, and you're looking at all of the site's security practices and policies as they relate to a process control system. You're looking at the network architecture to see if it's been built securely and reliably. Is it redundant? Is it not redundant? Do the switches and the infrastructure devices have reasonable configurations for security? Is the traffic that's flowing on the network only process control applicable traffic, or has something else been plugged in that may be causing some unwanted traffic to go across it? Do the employees working in the process control environment understand the importance of cybersecurity and what they should be watching for? And then the report saying, this is what you've done right, this is what you should make a little bit better, and this is how you should get to that industry best practice. One thing that needs to be brought right up front going in with a vulnerability assessment is the fact that this isn't an audit. This has got to be a collaborative, cooperative exercise. I came out of an FDA environment, and when the auditor walked in, he got put into a room, all the doors got shut, papers got put away, and everybody got told to sit at their seat, because you don't want that auditor talking to anybody, seeing anything, and asking any questions. These assessments, be it the risk assessments, the high level and the detailed, or the vulnerability assessment, are not audits. They have to be treated as a cooperative exercise in order to get the information required to make this a safe, reliable system. Generally, the elements that the vulnerability assessment follow are in the ISA 99 2.1 or the 62443 2.1 series of documents, and these spell out the major elements. The major elements that we do hit is the business rationale for the system. Why are you doing this? What is the benefit of going through these exercises? What is our cybersecurity vision that we are trying to attain? The risk assessment and identification, which includes the high-level risk assessment, the vulnerability assessment, and the detailed risk assessment steps. There we go. Addressing risk with a cybersecurity management system. What policies and procedures do you have in place? What's the scope of all of this? Just how much are you going to look at all at once? Do you have the staff and the organization that is devoted to looking at and mitigating cybersecurity vulnerabilities that could be exploited? Do you have a business continuity plan? This is one area where IT can be extremely helpful, because IT as a business environment and an enterprise environment has probably developed policies, procedures, and a full-blown business continuity plan. What needs to be made sure of is if these policies, procedures, and plans are going to be used within the PCN environment or the DCS environment, they have been modified to reflect the specific requirements of the PCN environment. And a very simple example for that is usernames and passwords, where in the enterprise world, everybody has a unique username and password. You will not share, you will not give it out. However, in the PCN environment, operator workstations, they generally all sign in with a group account. They don't go into screensaver mode if they're not used for a period of time, and you usually don't have to type in a password to use or a complex password to use the screen. So that's the normal way of doing things, and it's not a bad way of doing it. However, any policies and procedures which are in use need to reflect these specific requirements of the process control environment. Addressing risks, selected countermeasures, personnel security. Do you have background checks that are done for employees and contractors and vendors which are coming on site? Is the physical environment clean and safe? Clean and safe is not necessarily a cybersecurity issue, but it is a reliability issue. We were doing an assessment, and the computers had a fine layer of silica dust, sand dust on everything. And while that wasn't a true cybersecurity issue, what it was going to do is reduce the lifetime and the reliability of these computers, because there's a really good chance they're going to overheat and sporadically shut down. So in that respect, reliability was paramount. Network segmentation. Have you divided your network up so that only protocols which are required by your endpoint devices are getting to your endpoint devices? Are you using barrier devices that are limiting protocols as it goes? Have you made your access control so only people can only get to what they need to get to in order to do their jobs? Risk management, system development, as new things are done, as the process control environment changes, is a risk assessment being done on these new pieces or new applications so that you know what you're putting in maintains your cybersecurity risk? When you have an incident, if you have an incident, is there a manageable process in place to identify that you're having an incident, who to notify, when to notify them, and what do you do to make yourself better once you have an event that you've seen? What do you make changes to make your system more secure? And then conformance. Are you documenting what you're doing? Are you doing management of change for everything, including the infrastructure devices? Are you striving to make your cybersecurity management system better as you're learning things about it? These are all the key points that are done walking through the assessments, the actual vulnerability assessment. So the output from this should be a document which tells you what you're doing right, what you've done right, and then suggestions on what you can do better for the areas that you're not quite up to snuff on. But it's not that you're doing badly, it's that you just simply can do better in certain areas. And the output of this then gets used as an input to the detailed cybersecurity risk assessment, because you're looking at devices and you're looking at how these vulnerabilities can be exploited, what can happen, what the consequence can be. So the information required, it can't be gathered without the cooperation of plant personnel. Like I said earlier, this has got to be a collaborative and cooperative exercise. You can't come in with a chip on your shoulder and expect to get any honest answers and to be able to get any honest information. And it's not designed to find fault. It's designed to find out what you've done right and to document what you can do better and give suggestions on how you can get there. So that's the end of the presentation. I hope you found it interesting. I hope it was interesting and valuable. If there are any questions, you can type them into the questions log, and I'll get them and I'll answer them as best I can. So we'll wait a second to see if any questions come in.